Good afternoon, one and all, and I think we'll start the session within 2-3 minutes, sharp at 2:15. And Srimati K. Anuradha Madam will introduce resource person Dr. Y. Prashanti from Mahatma Gandhi University. Yes.
క్లాస్ అవుతున్నది అట్లా వచ్చి అవునా
Okay, Anuradha Madam. Hello.
హలో సార్ గుడ్ ఆఫ్టర్నూన్
Good afternoon, Madam. We'll back post-lunch session, sir.
Sir, wait for 2 more minutes, sir.
Okay. నేను మళ్ళా మనం టైం మనమే ఓకే అండ్ మురళీ సార్ కూడా ఇంకా జాయిన్ కానట్టుంది. మురళీధర్ రెడ్డి
will join on 3 o'clock, sir.
ఓకే అదే నేను చూస్తున్నాను. Guest owner.
Okay, sir. Shall we start? Kumar, sir.
Sir.
Shall we start, sir?
Okay. Good afternoon, one and all. And after lunch, we'll gathered for this national workshop. In the afternoon, as it is post-lunch session, and we gave the duration for the speakers 45 minutes. At present, from 2:15 to 3, we have Dr. Y. Prashanthi Madam, and 3 to 3:45, Dr. P. Muralidhar Reddy Sir. Now over to Srimati K. Anuradha Madam to introduce Dr. Y. Prashanthi Madam to the workshop.
Thank you, sir. Thank you for giving me this opportunity. Good afternoon, everyone. It is my great privilege to introduce our speaker, resource person of this session, Dr. Y. Prashanthi Garu, Assistant Professor of Chemistry, Mahatma Gandhi University, Nalgonda. She has completed PhD from Osmania University and postdoctorate from Taiwan. And she has research experience at IICT, along with the responsibility of the teaching faculty as chemistry faculty. Also, additionally, she has the responsibility as CDC coordinator, UGC coordinator, assistant director academic audit cell, department director of placement cell, coordinator for development cell, head department of chemistry, Mahatma Gandhi University, Nalgonda. Her research interests are in the areas of bioinorganic chemistry, nanoscience and nanotechnology, analytical chemistry, and synthesis of bioactive organic molecules. She visited USA, Taiwan, and Singapore to present her research work and collaborating with international scientific organizations. She has presented her research work at several national and international conferences. Madam has published more than 50 articles in various national and international journals. She has been on the editorial board member and as a reviewer for various international journals. She is currently working on a project and guiding dissertation and PhD students in the area of nanoscience, and will actively engage in organizing conferences, seminars, and science awareness programs. So far, more than 50 scientific programs organized to enrich the scientific knowledge among the students and teacher fraternity, and also given placement opportunity for more than 2,000 students in various organizations. I am very happy to invite you, madam, for today's session, and we are having you as speaker. It's a proud thing for us. Thank you very much. And with this, I will hand it over this to Madam Dr. Y. Prashanthi Garu. Thank you.
Thank you, ma'am. Thank you, Anuradha ma'am, for giving introduction about me. And very good afternoon to one and all. And first, my thanks to Principal Sir and Karunakar Sir, who is organizing this wonderful one-day national workshop on advanced technologies in biological and chemical sciences. And I extend my sincere thanks to all the faculty members and students of your college. And thank you very much. Yeah, ma'am, 1 second. Ma'am, is it visible, ma'am?
Yes, ma'am.
Yeah, thank you. And my topic is advances in nanoscience and nanotechnology. So why I have chosen this topic which is having enormous applications, which is having a wonderful opportunities for the youngsters in exploring towards the research level. We know everything about, means a little bit concepts about nanoscience and nanotechnology, but how far the applications are exploring to different areas. And I have chosen a particular area of research. So let's discuss about one by one. Structure. Yeah. So this, I belong to Department of Chemistry, Mahatma Gandhi University, and we are around 14 faculty members and serving, teaching, mentoring in academic activities and research activities. And this is our laboratory, because I feel pleasure to show about my university and my chemistry department laboratory. And this, see here, one small idea, a big impact, really wonderful thing. And it inspires me a lot. Always I feel something I have to invent. Every time I'm thinking to do something as a chemist, as a citizen of India, we have to feel proud that as a citizen of India, responsible person. So this idea reflects me to do the research in nano area. Small idea gives a big impact and a big result of the society, big information to the society. Really wonderful thing. How the small idea has been creating to give a wonderful concepts about nano. Here, nanoscience. First of all, nanoscience, then followed by nanotechnology. Science, we know, we are all science. And what is a nano? What's special in nano? For daily, we are using variety of objects at nanoscale level, but we don't know the exact literature or exact research going on around the world. So I feel it's a good platform to share my thoughts on nanoscience and technology. It's the science to study the phenomenon and the concepts about the materials at nano level. We know the technology, the application of science. Nanotechnology is the design and the characterization and application of the structures with the something different property or the new properties compared to the bulk one. I want to give a small example. In the slide, see here, bulk gold is equal to yellow. Suppose if you take a biscuit of gold, it's a golden yellow color, so that looks very bright, shiny, yellow in color. Suppose when you cut that big piece into very, very small, like micro level or nano level or whatever it may be, if you cut into very small pieces, the color totally changed, like a red color, something like orange color, means which deviates from its original color. It all depends upon the properties. So from compared to bulk material to nano, there will be a change in the properties, which is really a wonderful thing to explore further research at nanoscale. So what nanomaterial? Here different sizes are given, different shapes are given. Some are spheres, spherical, some are cubes, and some are fibers. Some are like roll spindles and nanorods and nanotubes. Variety of shapes are available. So nanometer is said to be the 10 to the power of -9th of a meter. If you take a diameter of a human hair, it is in micrometers. And if you take a computer chip, like 90 nanometer. So the structures with at least between 1 to 100 nanometers. So how these materials help us to study further research? Let's see here. Something. Wait for a minute, ma'am. Just it's a slide has dropped. Yeah, nanoscale. How? Nanoscale. Nano, where the word has been derived. It means a dwarf, very small thing. So the dimensions are between 0.1 to 100 nanometer. If more than that, it may not be considered as a nano. 1 nanometer is equal to the power of -9 of a meter. So, and who discovered and who is said to be the father of nanotechnology? He's a great physicist, American physicist, Richard Feynman. He is the father of nanotechnology. There is plenty of room at the bottom. A lot of work is there to do the research, to innovate the things. And Norio Taniguchi is a professor. He coined the term nanotechnology. And with this, the nano has become popular. And why we have to choose nano? Nowadays, everyone wants very small things with the wonderful opportunities. If you take the computer, it should not be a big one, very small things. Even computers, we can wear it on watches also. But not everything. We cannot observe those nanomaterials without naked eye. But how can we do the research in nano? Really a wonderful thought. So nanomaterials have very superior properties than the bulk. Just now I have given a best example that gold, bigger piece when cut into small pieces, naturally the color changes, the shape changes, then the entire properties will also change. Because of few flexible properties, this nanoscience and technology has become popular. And there are many challenges and variety of applications are there. Because of their mechanical strength, stability, magnetic properties, optical properties, size, and reuse. Because of all these properties, it has become a popular science. And applications, these are very simple applications. Because we are living in the nano world, so at least it's our responsibility to know the things. What the things are happening around us. Carbon nanotubes, we can use in the medicine, in IT, as a nanorobots, and as the energy. I will go one by one. How can we synthesize? First thought, we are very much interested to study the materials at nano level. Fundamentally, it's a very tough to observe with our naked eye. But how can we synthesize? How can we characterize? How can we stabilize the things? But variety of methods are there. The two include top down, bottom up. What do you mean by that? You can see, you can observe very clearly what this person is doing. Top down means he has taken a bigger one and he is cutting into small pieces. So start with the bulk material, cut it into pieces. This method also you can. And bottom up, he has taken very small blocks and building a big material. Reverse of that. So you can go either of the way. So the preparation includes the top down and bottom up approach. And we are wondering, such a vast applications does nanotechnology everywhere. We know only few things like electronics and medicine, but agriculture and cosmetics and paints also, solar, in textile industry, in electronics, in metallurgy. I have taken few examples, but we can feel that that a nanoscience and technology person can collaborate with any of the faculty, any of the discipline, like a physics person can do, like chemistry, defense, and agriculture person can do, a medico. In everywhere, it's an interdisciplinary research. So first of all, I have taken a simple exam where I have prepared. You please observe carefully. In this slide, you have a plant material, a algae, a fungi, and bacteria. And again, there will be some chart how the preparation has done. Which material is mixing with which material? And then what are these graphs? And what are the materials like UV, EDX, FTIR, SEM, and TEM, I think missed. What this slide indicates. I have taken a simple example where I have prepared. This is a general method, very simple synthesis. This is a biosynthesis where I have prepared iron oxide nanoparticle by using plants, algae, fungi, bacteria. How I have prepared. Here this clearly shows by taking this, I have grinded it. First I dried, then grinded, then I extracted, then filtered. After that, centrifuged. Then I got very clear nanoparticles. Then how can I characterize? I thought that with this I got nanoparticle, but I don't know exactly. How can I characterize? There are vast characterization techniques. Fundamentally, few can be used. I discussed in this talk also. Many characterization techniques. But fundamentally, we have to take TEM. I will explain what is TEM. And then SEM, UV, FTIR, and EDX. With this, by compiling all the data, we can conclude that iron oxide nanoparticle has been formed. This is very simple method. With this simple work, we can go further research, advanced technologies. We can find out the biomedical applications. When the particles are confirmed through the characterization, then we have to explore to further applications. This can be used as a biomedical purpose or other applications also. Yes. What are the characterization techniques? I told you, we have been prepared the iron oxide nanoparticle. Then what are the techniques? Microscopic techniques and spectroscopic techniques. Actually, in this talk, I have covered only one and two only. It's a vast subject to explain about everything. Scanning electron microscopy, transmission electron microscopy, and scanning tunneling spectroscopy. And what are other spectroscopic techniques which clearly gives information about the formation means the last five: XRD, small angle X-ray scattering, XPS, X-ray photoelectron, UV, and FTIR. Because we have to know in-depth analysis about the nano. Everybody is saying nano, but we don't know exact information and what type of applications are going on. That's what I want to start from the basic concepts. Next will be the transmission electron microscopy. See the picture, how the transmission electron microscope. It's a very costliest instrument. It will cover almost half the room. Kept at certain cool conditions. One technical person should be there to operate. You have to train to learn how to use the TEM. So what you will get the information from transmission electron microscope. It's a really costliest, like crores of rupees. We will come to know about the morphology, means shape, size, and how the particles are arranged in the sample. I will show the few examples also. Crystalline structure and composition. These are the things will be known by transmission electron microscope. And next will be the scanning electron microscope. Excuse me, sir, something struck in, not able to scroll down the slide.
Bhavani, is there any problem at our side?
Because not able to scroll the slide.
No.
Anything wrong from my side?
No, ma'am.
No? Okay. I think abstract. 1 second, ma'am. 1 second.
Ma'am, now it is visible.
Yes, ma'am. Now it is visible. It's
Yes.
moved, ma'am.
Yes, yes. Sorry, something what happened. Sorry for that. And again, scanning electron microscopy. This is the one more instrument, which also gives information about texture, surface of the sample. And again, the inner size of the particles, composition, again, the crystalline structure. These are very, very important. So just I have explained only, I have taken only the 2 examples. So I have given a few examples, TEM images where silver and gold nanoparticles. They have different shapes with the different size in nano. All the pictures we have taken it from transmission electron microscopy. Again, I want to show one more picture.
Will reduce and it helps in
Yeah, ma'am. And again, few more particles which are having the shapes of different size like flowers, cubes, and rods of different nanoparticles. Something happened, ma'am, so not able to scroll down. Really tough for me.
సో రెవెన్యూ ట్రీస్ అట్లా ప్లాన్ చేసుకోవాలి. సో ఈ రోజుకి రెవెన్యూ ట్రీస్ ఈ టాపిక్ అయిపోయింది కదా. నెక్స్ట్ ఆర్నమెంటరీ ప్లాంట్స్ ఇంకా 2-3 టాపిక్స్ ఉన్నాయి. అవి డిస్కస్ చేసిన తర్వాత we will go out for, we will see ఇంకేం ఆర్నమెంటల్ ప్లాంట్స్ ఇన్ ఇండియా ఉన్నాయి. తర్వాత నట్స్, ఆల్కహాలిక్ బ్రివరేజెస్.
Yeah, ma'am. Someone, I request someone to mute the voice.
ఫ్రూట్స్ అండ్ నట్స్, ఇంపార్టెంట్ ఫ్రూట్ క్రాప్స్ ఉన్నాయి.
Hello. Excuse me.
Please, Rachna madam, please put in mute.
Karnakar sir, something happened.
Yes, I inform.
It has been struck. I don't know what happened suddenly. So these are the few examples. Even we can use the application in the sunscreen lotions by using the nanoparticles, which gives the safer side. And the antifungal activity. Suppose if you take the crops, few crops which are being suffer with the fungal diseases. To cure the fungal diseases, we can use a nano silver particle. So how the silver nanoparticles can be prepared? By choosing different methods. So many applications like this. And when come to the part of next application, and food storage bins. So nowadays we want to use some storage foods. How can we use? I think if you use continuously, it will really dangerous for us by keeping in plastic boxes. But nowadays the food storage bins with the silver nanoparticle coating can be used successfully by killing the bacteria from food, and it can be stored and we can use without harmfulness. And next will be the treatment of cancer. Here you can observe so much of cancer cells, but the drug delivery, targeted drug delivery, how it will be. Suppose without nano drug delivery, if you inject or if you take the treatment, it may harmful to the total body and all the tissues. But by introducing targeted drug delivery system, where the cancer cell in that tissue, it will directly delivers the drug without damaging other tissues, so that the other tissues will be healthy. Really a wonderful thing for the patient who has been suffering with the cancer. The death rate will not be there. If you come to other technology like robotic technology, the robots in dental treatment, as the nanotechnology was introduced in the medical field also. So these nanorobotics, they will travel inside our bodies and they will get all the information, whatever the defects after delivering the drug. And even for the dental treatment also, it's really a wonderful thing for all of us, nanorobots technology. This will be in the medical nanorobots. And one more application we never heard also, in military science. See here, the military persons, they will wear uniforms that change the color to match the environment, because to escape from the enemies, they will change according to the environment. Like they will hide between the trees, then the color will be changed. and very lightweight bulletproofs also. And in the second picture, one person, he wear the jacket and the enemy, other enemies are going outside. Means the soldiers are the enemies they cannot see because we may become invisible. Such a wonderful research is going on with the nano. And this is the other method of the preparation, silver and gold particles with the other capping agents. And I have we prepared other nanoparticles with the gum acacia. With this gum acacia also, I have gone with the other applications like biological applications and the organic transformations. These are the 10 images of the palladium nanoparticles of acacia gum, where the structure and morphology has been confirmed. And with this, we have tried with the organic transformations, where the conversion from nitro to amine group, and we gone for some photocatalysis reactions also. Acacia with the platinum nanoparticles. And we have prepared at room temperature. Not only this, we have gone for antimicrobial activities also. We can't imagine such a type of broad applications are there for nanoparticles. And not only for the simple conversions, we can go for other conversions also. Just I have given a simple example by taking copper ferrite magnetic nanoparticles, where I got it from different journals, where the conversion from one organic to another organic molecule. And this is the other thing. We can remove the heavy metals from the water by using iron oxide nanoparticles to get the fresh water. And next, this is a little bit different story. Whatever so far I covered, the introduction and the applications in different fields. But my area where I am working is by taking the nanocatalyst, the pesticides, which are very harmful to the environment. How these pesticides will be good or bad. Let's see. What are pesticides? There are different kinds of pesticides. Insecticides, herbicides, fungicides to kill the fungus, and rodenticides to kill the rodents. I have taken few examples of the pesticides in my work. For here, I have chosen one pesticide. We have advantages and disadvantages of pesticides. For the disease control, we have to use, and to reduce, to get more crop yield, and to help the food production more by using pesticides. And side by side, we have bad also. What are the bad things if you take the pesticides? The main reason is really a bad thing for our health. If you take excess pesticides for the plant control also, really totally damages. If the excess pesticide, it will leak into the lakes, which affect the animals also. But overall, the pesticides are for the plant protection. And now I have taken in my research work, Propaquizafo, where I have taken this a synthetic compound. How I controlled by using the nanocatalyst for the environmental purpose. And additionally, pesticide and pesticide residues also there. Because when a crop is treated with the pesticide, some small amount of pesticides or some degradation products can remain in the crop. So my work is on the degradation of the pesticide residues by using nanocatalyst to protect the plants, to save the environment. So what are the residues remaining in the environment which are harmful? Means suppose if you take the water system, they pollute the air, and some are insect species, soil microorganisms, worms. By staying there, they weaken the plant root system also, and resistance and the immune system also. But how can we control? By taking the nanocatalyst in the agriculture sector, that too particularly pesticides. Because we know very well all the pesticides dissolve in water. So whenever the excess rain or excess water, they readily weep out into the rivers, lakes. The sea animals will take and consume it. It's very harmful to the sea animals. Finally, our aim is to protect our groundwater. So do not apply more pesticides if heavy rain is there, because they readily dissolve and leak out into that. So what I did, I have taken a simple concept. I have prepared the zinc oxide nanoparticle. I quantified or I analyzed the concentration of this in different samples, how this pesticide will not affect the environment. So I have taken a simple concept of by taking nanoparticles, and with the analytical method, I controlled. We know very well that it's our primary responsibility to protect the groundwater, because the accumulation of residues in the water reservoirs and other sources, they have direct effect on human population, even on aquatic organisms. So it is a must, the residues of herbicides and pesticides which are present in the tracer quantities have to be eliminated to avoid for the environment. Just what we discussed, if the excess rain will be there by using, whenever the pesticides are used, they readily dissolved and they come along with the river and they occupy in the river lakes. So this leads to the death of aquatic organisms. But how we can reduce this effect to protect our environment? Really, if excess is there, how it affects the human health? Parts of the body absorb pesticides at different rates, head, brain, and genital area, when we observe the pesticides directly. So to control over these, many techniques were developed, analytical methods by using nanocatalyst. So how to overcome all these challenges? What are the analytical techniques used to reduce this? Because these are the experiments: GC, LCMS, and UV photometer. With this, by different instruments, we can reduce the pesticides. So I prepared the zinc oxide nanoparticles, and I have taken the TEM images. This is the synthetic method, where the zinc oxide and pesticide has mixed together, then filtered and sonicated, and I have taken the results from the GCMS. Then I find out how much pesticide was removed. These are the images, and I have done a simple experiment by exposing that to the sunlight. And after that, I have chosen other experiments also. Then in this situation, what we have to do? Because it is must to protect our environment. Lot of measures have to be taken. But in this, the nanotechnology I have taken a simple concept for my research purpose, but we can do wonders by taking nanotechnology. We can filter the water to get very clear drinking water. And one more thing, we can convert air into water by using nanotechnology. The IIT people, they are doing work on this. And we are collaborating with a few IITs for removal of fluoride, like fluoride filters, to get the fresh water. So the research is must, and the awareness for each and every person is must. As a chemist, it's our primary responsibility to do the research, and to by our research, the societal application should increase. Not for one purpose like doing research is not must. The societal problems have to be resolved. Not only the organic or inorganic or physical, it should be some interdisciplinary, whatever it may be. It should cross, like a multidisciplinary research has to be approached. Our target is protect yourself, family, neighbors, and pets as be a responsible applicator. So just I want to conclude my talk. In the modern agriculture, the use of pesticide is must, but proper and efficient use has to be done. So alternative strategies are, you can go for the nano pesticides or biopesticides, which doesn't have harmful to any of the human beings or aquatic organisms. So with this, I conclude my talk, and thank you very much for the opportunity given on this virtual platform to interact with all of you.
Prashanti,
Thank you. Karunakar.
one question.
Yes.
After you are prepared silver and iron nanoparticles,
Yes.
biosynthesis of nanoparticles.
Yes.
After preparation of these nanoparticles by using any medicine plant part or any gum, what is the process required for getting characterization and getting spectra?
Means we have chosen the different procedures, like after the preparation, it has to be sonicated, and the material, whatever the material we got, directly we have given it for the TEM and SEM images and other characterizations to confirm the nanoparticle formation.
Okay, thank you. Is there any doubt? Any question? Just 1 or 2 minutes.
Yes, sir.
Okay, if there are no questions from the participants, I request Bhavani Madam to present a vote of thanks to our Madam, Prashanti Madam, for sparing her time for this national workshop.
Okay, sir. Very good afternoon, everyone. Good afternoon, Principal sir, and good afternoon, Karnaka sir. Good afternoon, Prashanti ma'am, and each and everyone. To my students and colleagues, everyone, participants of this webinar. So thank you, Prashanti madam. Today we got enlightened with many topics regarding nanoparticles and nanotechnologies, and we are very interested regarding your research. It is very awesome, and with your slides we got content very clearly. We got to know many things about nanotechnology and about practically use of such equipments and some of the devices which we need to do that, and like scanning electron microscopes and usage of nano robots for medical research, and how to remove that unwanted things are unnecessary from waters, like pesticides from agricultures, and lastly you gave a nice conclusion about how we can implement this in our modern world. So thank you, madam.
Thank you.
Thank you, everyone. I request Vinay sir for
Okay.
continue of the program.
Okay. Thank you, madam. Thank you all the participants in the workshop. Now it's time to introduce our next resource person, Dr. P. Muralidhar Reddy sir, presently working as Assistant Professor, Department of Chemistry, Osmania University. And sir is working since 2013. Sir completed his graduation, post-graduation and PhD from Kakti University. And sir worked as a visiting faculty member at Tzu-Chi University, Hualien for 2 months in 2014. Sir also worked as postdoctoral fellow at National Donghua University, Taiwan from August 2007 to September 2013. And during Sir's period, Sir focused on the synthesis, characterization of nanoparticles towards biological applications, and identification of the microorganisms by electrospray ionization, matrix assisted laser desorption ionization, mass spectrometry techniques. During the period of Sir's doctoral research work from 2002 to 2006, Sir has developed various methodologies in inorganic and analytical chemistry. Sir has industrial experience in analytical research and development, Hetero Drugs Limited, Hyderabad, India. Sir authored 5 books and 90 research articles, which have been published in reputed international national journals with H index of 23, I-10 index of 37, and 3 patents for Sir's credit. Sir also presented research papers in 75 national and 38 international conferences. Sir delivered guest invited lectures in various colleges, conferences. Sir also life member of Indian Council of Chemists, Indian Science Congress Association, Indian and member of Taiwan Society for Mass Spectrometry, Taiwan. Sir, reviewer of over 20 national and international professional journals. Sir has 15 years of teaching and 20 years of research experience. And Sir research focuses on coordination chemistry, bioinorganic chemistry, organometallic chemistry, biological activity, catalytic applications on drugs, synthesis and development of functionalized magnetic iron oxide, titanium dioxide, and silver nanoparticles towards biological applications and developing mass spectrometric methods for analysis of various microorganisms. And Sir supervised so far 21 PG, 5 MPharm, and 3 PhD students completed their dissertation work, and 8 scholars are currently working for their PhD degree. Sir research activities, so total 6 major projects, 3 international and 3 national, and supported by various funding agencies like NSC Taiwan, Tzu-Chi University, UGC, DST, and CSIR New Delhi. Sir served as member in several committees of Nizam College, Osmania University from October 2013 to 2020 January. Sir worked as placement officer Nizam College, Osmania University from August 2014 to July 29, and controller of examinations at Nizam College, Osmania University from October 2018 to February 2020 currently. Sir is a joint secretary, Osmania University Chemistry Foundation, coordinator for Human Capital Development Center, Osmania University, and placement officer, UCS Osmania University. And Sir as honored with this ceremony honors Best Teacher Award in 2015, National Builder Award 2015 for the cause of educating the future generation of our country. Fifth, that is given by Rotary Club on 5th September 2015. And Sir is also a recipient of Ideal Teaching Awards 2018, selected in the category of Professor of the Year Chemistry, and Seva Ratna Award 2020 for Sir's outstanding individual achievements and distinguished service to the nation on 26 January 2020 by Organization by Youth for Social Transformation and Environmental Recoup, a registered NGO 442/09. Sir, also recipient of Mother Teresa Gold Medal Award 2021 by Global Economic Progress and Research Association, Tamil Nadu, India. Sir received Best Paper Presentation Award, ranked first in ICNN 2011, RAC 2015, NPC 2020, and in CPCM 2020. Sir received 2 gold medals in BSc and MSc and received the Popular Student Award in 1999. Muralidhar Reddy sir, on behalf of our principal, teaching and non-teaching staff and the students and all the delegates and the participants, I welcome you for this national webinar, for giving your time to spare your valuable time during for our webinar. And I once again welcome you, sir. Thank you for being with us. Over to you, Muralidhar Reddy sir. Thank you.
Thank you very much, sir, for a nice introduction. And I think this is my second time I am giving the presentation in the Government Degree College Sadashivpeta.
Yes,
I think the last conference also I have given. I think
Yes,
in the
yes.
national conference I have given a talk in the Sadashivpeta Degree College. I think Vinayaka sir and Karunakaranna is there. Karunakaranna is my super senior during my MSc. So thank you very much, Karunakaranna, and also Prashanti Madam, namaste. And other Dayanand sir, so many degree college. I know Vijayalakshmi Madam, so many faculty are there in the today's meeting. And also my students also joined. So thank you, Vinayak sir, for a nice introduction. And about actually today's I'm going to give some different topic which is related to somewhat biology connected with the chemistry, particularly it's on the analytical chemistry, but I can simply say that it's a bioanalytical chemistry. It's a biology because the conference is on the both biology and advanced technologies in the biology and chemistry together, and so therefore I have chosen this topic, and also we have done this work with my collaborator Taiwan. Actually, I have some 2 projects are currently running with the Taiwan professor, and in that this is also one of the completed project. But anyhow, those results I am going to share now. So can I share the screen? Yeah. This is about my topic. One minute. There is but I am not able to. Yeah. So evaluation of the vitamin D deficiency. 1 minute, I am not able to. 1 minute. I'm not able to full. Yeah, okay. About the evaluation of the vitamin D deficiency by a rapid and cost-effective advanced mass spectrometry approach is today's my topic. First, about the outline of my talk is the first we'll discuss about the introduction about the vitamin D. So what is vitamin D? And also the what are the sources of vitamin D, and what is the recommended dietary allowance of vitamin D, and what causes if the vitamin D is deficient in our body, what are the effects caused by the vitamin D. And I think due to this pandemic in the corona time, it has a lot of importance, particularly vitamin D. I think when you go for a treatment of corona, either Delta or Omicron, whatever it may be, they are suggesting the vitamin D tablets. So I think as per my knowledge, if you test 90% are the vitamin D deficient. According to me, I am the vitamin D deficient person, and myself and my wife and my son also, we are all are the have the vitamin D deficiency. So that's that is the because of current lifestyle and living style, and we are not exposing sunlight. There are several reasons for the deficiency of the vitamin D. And current scenario of the vitamin D deficiency in India, particularly present situation. This is there are a lot of research work is going on about the vitamin D deficiency in India and the current scenario. So this is the one outline of my talk, and also overview of the advanced mass spectrometry techniques. And present days, the mass spectrometry is one of the most essential technique, particularly for those who are going to work in the industry. Without mass, there is no FDA approved or whatever it may be. There will be a chromatography corrected with the mass spectrometry. These are the very essential techniques, particularly whatever this may be in the pharma industry or whatever it may be industry. It will be the chromatography coupled with the mass spectrometry, one of the important techniques. And in that one, I'm giving some overview about the advanced mass spectrometry techniques. What are the current mass spectrometry techniques which are used in the industry, and also the detection of the vitamin D deficiency by a rapid, and we have developed one method, rapid and cost-effective advanced mass spectrometry method. So with our method, if you have the instrument, you can detect the vitamin D deficiency with the 50 rupees of cost only. So this is one of the method. We still now we are going for the patent for this method, and comparison of the vitamin D levels with the people levels in the people with the different food habits. Because in India we have different food habit people. Some people are non-vegetarian, some people are the vegetarian, some people are the vegans, and some people they will not drink even. Some people, particularly some kind of community, they will not drink a milk. So they will not drink any animal product. Those we call it as a vegans. And also conclusion of my talk. So first, let me start with the introduction about the vitamin D. So it is a fat soluble vitamin. Vitamin D is it is a sterol. It is a fat soluble sesquiterol. What is the main role of vitamin D? So it is responsible for the increasing intestinal absorption of the calcium, magnesium, and phosphate. When you are taking the food, there will be calcium, magnesium, and phosphate should be absorbed from intestine to the blood. So for absorption, this vitamin D will help to absorb of calcium, magnesium, and phosphate. And also it has many other biological effects. So it is one kind of steroid. Its name is a cyclopentoperhydrophenanthrin ring. It contains it is a steroid unit. Generally, we know the vitamin D, but actually vitamin D is occurs in the two forms. One is the vitamin D2, another one is the vitamin D3. So vitamin D2 is the ergocalciferol and vitamin D3 is the cholecalciferol. So these are the structures of the vitamin D2 and vitamin D3. When you see the structures, so only the difference is here, this portion, whereas ergocalciferol has the excess of methyl group and double bond. And whereas vitamin D3, this is absent in the vitamin D3, but the remaining structure is the same. So only the difference at this portion, only the whereas vitamin D2 has the excess of methyl group and double bond, whereas vitamin D3 does not have that one. So generally, this vitamin D2 mostly found in the plants, and whereas vitamin D3 found in the animals. Mari, what are the required dietary or recommended dietary allowances, and how much we required per day vitamin D? So for it comes to the children's, so it requires the 10 milligrams per day, or like nowadays we are getting the tablets in the form of IU, international units, and 400 IU per day, and adults 5 grams per day or 200 IU per day, and also above 60 years of age people require the 600 IU per day, or maybe the pregnancy, those who are in the lactation period, that time 10 grams per day or 400 IU per day is required. Generally, when you expose to the sunlight, automatically we will get the vitamin D. How it is synthesizing? When you are exposed on the sunlight, the 7-dehydrocholesterol is converted into the cholecalciferol in the skin. So this is the automatically, naturally, with the help of sunlight, our our skin is synthesizing the vitamin D3. But sometimes, like the production of vitamin D, if you want to see the production of vitamin D in the skin is directly proportional to the exposure to the sunlight, and how much you are exposing, automatically the production of the vitamin D is increasing. But sometimes maybe if you do depending on the season, maybe depending on the country, and maybe some of the countries you will not get the UVB radiation. So in those countries, maybe may not be possible to synthesize the vitamin D by the skin. So nowadays the vitamin D deficiency is recognized as a global pandemic. So what are the reasons to deficiency of the vitamin D? So the first reason is the diet. Maybe we are not taking the proper diet for the vitamin D related diet, or maybe you are not exposing to the sunlight, sun exposure, and lifestyles where you are living, and also your living area. So for example, if I am living in an apartment which is in the ground floor, there is no sunlight exposure every day. So living area, and also season, and depending on the sometimes in the winter, some countries you will not get, they will not see sun more, some of the seasons, and also the skin color also will affect, and also the age also. These are the several reasons for the deficiency of the vitamin D. So it is recognized as a present global pandemic, and currently also the vitamin D in the COVID time also, this is a very important vitamin. And what is the problems if you the vitamin D deficiency? The deficiency of vitamin D causes the major problem is, one is the rickets in the children and osteomalacia in the adults. So one is the I think you know the rickets. So it is a vitamin D deficiency, particular state in the children. So it maybe there are two reasons, and dietary deficiency with proper diet. This, if you are not taking the proper diet, maybe you may get the vitamin D deficiency, or sometimes if you are not exposed to the sun also, it causes the vitamin D deficiency. So generally the rickets in the children is characterized by the bone deformities due to the incomplete mineralization, and causing enlargement of softening of bones, and delay in teeth formation, and also and due to this, some biochemical findings also observed in our body, a decrease in the serum calcium, decrease in the plasma phosphorus, and also the these are the causes of the this is caused due to the lack of vitamin D. in your food or in your blood. So second is the osteomalacia. This is caused particularly in the adults, and this is also inadequate exposure of sunlight or low dietary intake, and generally demineralization occurs mainly in the spine and pelvis, and bowing of the leg. Long bones may occur due to the weight of the body. These are the osteomalacia. If you take excess of vitamin D, also it is toxic. So generally, vitamin D is stored mainly in the liver. So vitamin D is most toxic in the overdose. The toxic effects includes the demineralization of bones and increased calcium absorption from the intestine. Automatically, when the vitamin D is more, automatically it will excess of calcium absorbed from the intestine, leading to the an increased plasma calcium. It is called as a hypercalcemia. Sometimes this hypercalcemia leads to the kidney stones. Kidney stones, that kind of disease may be due to the. This is also one of the reason. And the excess of absorption of calcium from intestine to the blood, it causes the kidney stones. These are the deficiency of the vitamin D causes the, particularly for children, it causes the rickets, and also for the adults, it causes the osteomalacia. And also, if the vitamin D is excess, it causes it is a toxic. And in addition to these diseases and the deficiency of the vitamin D causes also the hypertension and myocardial infarction, and also heart stroke, and sometimes diabetes, and also the particularly most of the they are also suggesting that the cancer also one of the disease which is caused due to the lack of the vitamin D deficiency. So that is the reason. So what my suggestion is, the test for the vitamin D test, and maybe so it may help to you can take some supplements, or maybe you can take some diet to increase the vitamin D deficiency in your to increase the to cure the vitamin D deficiency in your blood. So okay, there are the reasons, and of the due to the deficiency of vitamin D, it causes the rickets, osteomalacia, hypertension, stroke, diabetes, and cancer-like diseases. So these are the some observations. And rickets, this is the 1930. So one brother and one sister, 10 months old girl, and 2.5 years boy. So maybe after 4 years, the bones become the impeded growth of and soft and weak and deformed long. So this is the before picture. This is the after picture. So this is a kind of disease, particularly you will see in the most of the African countries and this kind of countries, because they cannot, because their skin is the dark, maybe. So there is the, if they are exposed to sunlight also, maybe vitamin D is not able to synthesize. That is the reason they have to take a dietary intake, and from the food they have to take the vitamin D. So this is about the metabolism, how it is vitamin D is converted into from sunlight to the body. This is the sunlight, and it is finally it is 7-dehydrocholesterol is converted into the vitamin D, and it is going to stored in the liver. This is about the metabolism of the vitamin D in our body, and particularly how if you see the vitamin D3 in presence of UV and B radiation. So here the bond is getting breakdown here, and this 7-dehydrocholesterol is converted into the vitamin D3. So this vitamin D3, human body can synthesize this vitamin D3, and also this vitamin D3 you can also get it from the diet, like mostly for fishes, milk, and particularly egg. Maybe you cannot say 100% milk, and fish will the richest source of the vitamin D3. And vitamin D2 are not synthesized by the human body. You have to get it only from the diet. So particularly, you could able to get it vitamin D2 from the vegetables and algae. So these are the both the vitamins which are available in the human body. So according to the Nutrition and Health Survey, this is the report I have taken from the net source and Nutrition and Health Survey, and they have conducted this survey around 2,600 members. So when they see the according to this survey, so they have given the 4 categories. One is the serious deficiency of people, and the people whose vitamin D deficiency is less than 8 nanogram per 1 ml of blood. The people who are less than 8 nanograms per ml of blood, we call it as a serious deficiency. And the deficiency is 8 to 20 nanometers and nanograms per ml blood. And inadequacy and 20 to 30 nanograms per ml. And sufficiency is greater than 33 nanograms per ml. Just depending on the country, it is changing. Some above, it should be above 30 or 35, and depending on 32, maybe 40 or 45, depending on the parameter, test parameter, they are giving this sufficiency. But according to this Nutrition and Health Survey, so when they observed, almost 63.8% are the vitamin D deficient people. So 63% of people are the vitamin D deficient. Serious deficiency are only 2.4%, but only less than 2% only in the sufficiency. And for example, if you take 100 people, in the 100 people, 2 people only has the sufficient of vitamin D. Inadequacy means they are between, it means deficiency and between the vitamin D is around 20 to 30 milligrams per nanograms per ml. So around 32% people are there. I am here only, inadequacy only. Okay, so this is according to the Nutrition and Health Survey. And then also this is the current scenario of the vitamin D deficiency in India. So they have tested so many, like thousands of people around it. Here you can see the VDD means vitamin D deficient, approximately 60% of the people. And they test, this is a number, 15,452 people deficiency unnadi, and 8,970, and 34% of people vitamin D insufficient, and it is in between 20 to 35, or here they have taken the parameter 20 to 40. And only VDS means vitamin D sufficient people, only 7% people are there. This is particularly for the Indian survey. So that means the vitamin D is sufficient is less than 10%, 7 or 8, 2%, 3%, like that. So that means we have to change our lifestyle to get the more vitamin D to our body, and also you have to take the proper food for the means vitamin D rich foods you have to take. Okay. Next. And this is the current scenario. So this is the average concentration of vitamin D in the different countries. If you see Taiwan, approximately 18.9. It is nanograms per ml. And if you see the Korea, 17.1, China 25.3, US 23.4. This is the men. And UK 19.3, and Portugal 23 nanograms per ml. And also if it comes to the women, this is also different years. This data are collected from the net source, and 2015 to 16, this is 21.3, 19.8, 23.3. So these are the average concentration of the vitamin D deficiency, okay, in the different countries. Okay. Next, these are the guidelines of the vitamin D status by the blood concentration. What are the guidelines? If you say if the vitamin D deficiency is the less than 8 nanograms per ml, then we call it as a serious deficiency. If it is between less than 20 nanograms, then we call it as a deficiency. Less than 30, 22, in between 20 to 30 or 33, I can say, up to the, we call it as a nanograms per, we call it as a inadequacy. And greater than 30, we call it as a greater than or equal to 30, we call it as a sufficiency. And less than 100, if it is the vitamin D is more than 100 nanograms per, then it is, we call it as a toxicity. So there are the guidelines for the vitamin D status by the blood concentration. So therefore, for the detection and of vitamin D is very important. And also we know the lot of present vitamin D deficiency is estimated, or vitamin D concentration in the blood is estimated by the conventional methods like chemiluminescent assay method. And in addition to that one, we have developed different mass spectrometry methods like advanced mass spectrometry method, by taking the advanced mass spectrometry method for the detection and identification and quantification of vitamin D in the different plasma or different blood sample. We utilized the different techniques, and also we have used the different methods. And in the some of the techniques, we used the LCMS and also LCMS method, and gas chromatography coupled with the mass spectrometry, and also the GCMS gas coupled with the MS methods. And also we have also done the comparison of the vitamin D levels in the people with the different diet habits. And also after the comparison, we also validate the new detection techniques with that of the standard techniques, because what we have developed a technique, we should be, it is exactly detecting like what are the conventional method or not. Then we have validated with the conventional methods. Before going to this one, and how does mass spectrometry works? So these are the, generally mass is the one of the very important analytical tool which is used in the pharma industry, particularly in the bioanalytical and these labs. And also it has various applications. It has applications in the not only single field, it has applications in the environmental, forensic, and food industry, and also the pharmaceutical industry, particularly impurity profiling, and so many applications are there. So without, I think, without the mass spectrometer, there is no, I think, no pharma industry go. Right? And so there are the basic components of the mass spectrometer are the ion source and mass analyzer and detector. Here we are going to inject the sample. Ion source, the role of the ion source is it makes the ions, and the mass analyzer, what the role, it separates the ion based on their mass to charge ratio, and the detector will detect the ions. And generally there are the two basic principles are there. If it is the generally in the mass spectrometry, one, it is going to be ionization. So the molecule is going to the ionize. So if it is a molecule, when you hit with the high energy electron beam, maybe approximately 70 electron volts or whatever, maybe if you hit with the electrospray ionization, or if you hit with the tungsten filament, and the molecule is undergoing, and by losing one electron, it is forming a radical cation. So this radical cation, we call it as a molecular ion. Generally, this molecular ion is unstable, So it is readily decomposed into the various fragment ions. These are fragment ions or dart ions. So by detecting these dart ions, you are going to get the information for the structural elucidation of that compound. This is the basic principle. And also, if it is non-volatile substance, some compound may not be volatile, or some maybe if you use the high energy, maybe it may break the molecule into the very small fragments. For that reason, you can also use soft ionization techniques, like maybe you can add some matrix or some solvent. So from you can also add the protonating agents to then you will get like the M plus H peaks or M minus H peaks. So this is the basic principle of the mass spectrometry. And this is about the block diagram of the mass spectrometer. Generally, mass is the highly sensitive instrument. So where you can this ion source and mass analyzer and detector. These are the three will be under high vacuum. This high vacuum is maintained by the turbomolecular pumps. So in the mass, if the mass is coupled with the chromatography, for example, here I have given the inlet. You can directly inject your sample into the mass spectrometer, or you can separate the components with the help of the chromatography. If you couple the HPLC with the mass spectrometer, we call it as a, so this I am giving, this is the mass spectrometer. This is HPLC. And a LC, then we call it as a LC-MS. This is MS, LC-MS. Maybe if you couple with the gas chromatography here, GC-MS. If you couple with the capillary electrophoresis, CE-MS. Maybe if it is the MALDI, you can use a sample plate for the. So these are the inlet. Through the inlet, you are going to inject your sample, or you are going to put your sample into the mass spectrometer. Once if your sample is reached to the ion source, so ion source, what is the role of ion source? It makes the ions. So there are different ion source. Based on the different ion sources, we have the different kind of mass spectrometer. That's why EI mass spectrometer, CI mass spectrometer, electron ionization mass spectrometer, CI mass spectrometer, FAB mass spectrometer, fast atom bombardment mass spectrometer, ESI, electro spray ionization mass spectrometer, or MALDI-TOF matrix assisted laser desorption ionization mass spectrometer. Based on the ion source, we have the various mass spectrometers in the, and and mass analyzer. The next part is in the block diagram, mass analyzer. What is the mass analyzer? So it separates the ions. What the ion source will do? So depending on the ion source, it makes the ions. So what the mass analyzer will do? It separates the ions. So based on their mass to charge ratio, there are the various mass analyzers are there. So the commonly used mass analyzers are the time of flight mass analyzer, TOF, and quarter pole mass analyzer, and ion trap mass analyzer. These are the most commonly used mass analyzer. In addition to this one, magnetic sector and also FTMS mass analyzer also is there. And after the separation of these ions, so detector, finally it is going to detect the ions. The most commonly used are the microchannel plate or electron multiplier detectors are the commonly used detectors. So, and if the mass spectrometer contains more than one mass analyzer, those mass spectrometers are called as the tandem mass spectrometer. And for example, like if I have taken the HPLC coupled with the mass spectrometer, then we call it as a LC-MS. Or I have taken gas chromatography coupled with the mass spectrometer, then we call it as a GC-MS. For example, if we go more in detail, first I have taken HPLC, and for ion source I have taken a ESI and a LC ESI, and for mass analyzer I have taken a ion trap, LC ESI ion trap mass spectrometer, LC ESI ion trap mass spectrometer. For example, I have used the two mass analyzers. So then we call it as a tandem mass spectrometer. For example, same HPLC, LC coupled with the ESI, and I have used TOF, time of flight mass analyzers. Therefore, then we call it as a LC, ESI, time of flight mass spectrometer. For example, if you take GC, gas chromatography, coupled with I used a electron impact or electron ionization, GC, EI, and I used 3 mass analyzer, time of flight, quadrupole, time of flight, or time of flight, or quadrupole. I use GC, gas chromatography, electron ionization, quadrupole mass spectrometer. This we call it as a tandem mass spectrometer. That's why we have written a LC-MS-MS. If we use 2 or more mass analyzers, then we call it as a tandem mass spectrometer. Here the some of the components of the mass spectrometer. So by like this gas chromatography, liquid chromatography, your compound will enter through here. Ion source, here it makes the ions. Mass analyzer, it separates the ions. Detector will detect the ions. So I will go for this is the difference between MS and MS-MS. And if you use, for example, here I have used the first one is the MS, mass spectrometer. Inlet, ion source, mass analyzer, detector. This is the basic components of the mass spectrometer. Whereas where it comes to the tandem mass spectrometer, so inlet, ion source, there are 2 mass analyzers. One is MS1, another one is another mass analyzer. So what the first mass analyzer is doing, whatever the chromatography is doing, that work is doing first mass analyzer. What is the use of the chromatography, gas chromatography or HPLC, capillary? It separates the components. For example, M1, M2, M3 components. It is separating into the M1, M2, M3. And the first mass analyzer, what it will do? It separates the components. First mass analyzer. And whatever the chromatography work is doing, that work is doing by the first mass analyzer. And in the collision cell, this first mass analyzer undergoing the fragmentation. And second mass analyzer, what is doing? It is identifying the what are the components are fragmented in the collision cell, and second mass analyzer separating those components, and detector is going to identify. This is about the MS and versus MS-MS. And if it comes to the here, this is MS and this is MS-MS, GC-MS, this is MS-MS, and this is GC-MS-MS. Yeah, you will see by comparing this way, will come to know the basic picture about because the fundamental concept is for our study, for my study is this only. For the MS, okay, we have taken M-ion. M is undergoing the ionization. We'll get the M1 plus MX2, M1X plus and M1Y ions, mass spectrometer identifying. And if it comes to the GC-MS, the reference, you have the 3 ions, M1, M2, M3. What the GC is doing is separating M1, M2, M3 and mass spectrometry identifying. Now I am interested only M1. Therefore, M1 is undergoing the ionization, M1X plus, M1Y plus ions, and mass detector detecting. Whereas the same M1, M2, M3 ions, in the first mass analyzer, what it is doing, it is converting into the M1 plus ion, M2 plus ion, M3 plus ion. So I am interested, first mass analyzer separating. I am interested only M1. And finally, second mass analyzer, collision cell, this M1 ion is undergoing the fragmentation, M1X plus, M1Y plus, and this is the MS-MS. So if you couple MS-MS with the chromatography, and you will get a very accurate information. Nowadays, most of the pharma industries are using LC-MS-MS, GC-MS-MS techniques only. So what that is going to do, M1, M2, M3. So these ions are going to separated by GC. It is separated into M1, M2, M3. First in the first ionization source, M1, I am interested only M1. First, what is happening? M1 is fragmented into M1A plus M1B and M1C and like that. So the mass analyzer, first mass analyzer separated into M1A, M1B and M1C. But I am interested only M1A ion. Then I send this to the reaction region. So this M1A is converted into the M1A plus M1A. Again, it is undergoing the fragmentation. M1A X plus M1A Y plus M1A Z plus, and then you will get the information of the second mass analyzer. This is about the GCMS. Similarly, LCMS also. So the advantage of the tandem mass spectrometry is the, for example, you have recorded a one compound spectrum. First, you have injected sample here. First, you got the one kind of mass spectra. But you are in your mass spectra, you observed that this peak, wherever I highlighted the red peak, this peak you thought that it is a unknown peak. But you want to know about this peak, then you can select this one, this ion, and you can do the analysis. Then you can send this ion into the collision cell. This ion is undergoing the fragmentation, and it will you will get the for this ion mass spectra here. And so more accurate and more precise information you are going to get it from this kind of tandem mass spectrometry. So similarly, it is the LC-MS also similar like HPLC. Here HPLC you could able to separate this like square, triangle, circle ions. So in the first quadrupole, what it is going to do? You are only I'm interested only circle ions. Then I have sent it to the circle ion. The circle ions are separated and it is gone to the collision cell. Collision again, it is undergoing the fragmentation. Second quadrupole ion, and finally you are going to detect these ions. So I'm going little bit speed because of the lack of time. So if you see the overview inside of the instrument, it will be looks like this. First quadrupole mass analyzer, collision cell, and this is second quadrupole mass analyzer or time of flight or magnetic cell. This is the over. MS1 will be there like inside. And currently there are in the industry this triple quadrupole, and one of the quadrupole mass analyzer, one of the quadrupole acting as a collision cell. So this is a triple quadrupole mass spectrometers are available in the particularly in the pharma industry current day nowadays. So these are how it looks in the industry. This is the way also in your lab LC. This is the LC coupled with this is the mass spectrometer. And these are the we have and our aim is to estimate the vitamin D in the plasma samples. So before going to this one, we have developed a method. So before developing a method, we have prepared the sample preparation. So after preparing the sample, we have used this sample for the LC-MS and also GC-MS and GC-MS and also LC-MS. And the important is that we have used the different methods. One is the internal standard method, and one is this is the, you can see the internal standard we have here. We have modified here 3 hydrogens with the deuterium. Here the mass is 400. Here mass is this D625 hydroxy vitamin D3 as a internal standard we have taken. And also for the derivatization, we have choose the 2 reagents. One is the Amplifex diene reagent, and another one is the bis trimethyl silyl estimate reagent. So these are the reagents which are this reagent is selectively coupled with the vitamin D3. So we have applied, these are the methods LC-MS, LC-ESI, MS-MS, whatever is the GC. And also finally we have compared our method with the chemiluminescent immunoassay. It's a conventional methods. These are the, when you run the column, so this you see the first one is the internal standard. You will see the internal standard peak is there. And we have run with we have taken the different standards of vitamin D. And from the 12 nanograms to the 25 nanograms per ml, 50 and 100 and 10. So we have validated the method. And is the actually is the standard is coming the same with the same peak, with the same retention time or not. So by this way. And later the second method is the derivatization method. Here we have used a simple Diels-Alder chemistry. Here you can see in the vitamin D structure, there is a diene. Here diene is there. So we have added this is dienophile. Dienophile, it is the Amplifex diene reagent. Automatically this dienophile is interacting with this diene and forming a adduct, the mass of the adduct is 732 and the actual mass of the vitamin. So by this derivatization also we can detect the vitamin D in the plasma or blood sample. And we also validated this method and we got the very good R square value. And later, and we also used the this trimethylsilyl acetamide. I think when you observe the vitamin D structure, there are the hydroxy groups. Here hydroxy, here hydroxy. So then when you add this trimethylsilyl derivatizing reagent, automatically this hydroxy group, OH group, this H is replaced with this trimethylsilyl. Automatically, so this compound here, this compound mass is the vitamin D mass is the 400. So automatically with the trimethylsilyl group, it is converted into the 544, and also the volatility of the compound, also D vitamin also increases. So this is the, I think this is the first time we are reporting. So till now, so far, no one used the gas chromatography for the, particularly for the detection of the vitamin D. And this is the, this method also we have validated. And when you see the, this is the 0 nanogram, there is no, and 12.5 nanograms, you see the automatically the intensity of the signal is increasing with the gas chromatography method. So 12.5, 25, 50, and 100 nanograms. So this is all, this method also we have validated. And then we have taken the plasma samples like blood sample with the, just I am giving the one to only here. So 2 persons plasma samples. So this was about the, this is the internal standard here, where the around 11.5 minutes you got the peak. And also the plasma sample, we have this is the intensity, 100 nanograms per ml. With the plasma one, first person plasma sample, we got only 19 nanograms per ml, and that person has only 19 nanograms of vitamin D in the, and it is a second person plasma sample 15.2 nanograms. But then also we have validated, because we have got the information, but maybe this may be correct or may not be correct. And then we used the, we have same samples, we have done the immunoassay with the chemiluminescent immunoassay. And the results, if you see, in the conventional method, we got the 18.8 nanograms per first person blood sample, 19.8. For the traditional method, 15.7. Conventional method, 15. But our methods, if you use GCMS or LCMS or GCMS-MS, approximately these results are the same. So 19.8, we got the GCMS 19.2, LCMS-MS 19.5, and GCMS-SA method 18.9. Similarly here. So that means, so our results are almost similar with the conventional methods. So by this way, we have analyzed the real samples taken from the almost 120%, 117%. In that one, we have selected the 47 non-vegetarian people, 46 vegetarian, and 24 vegan people. Vegan means those who will not, even though those will not take the milk or animal protein, they will not take milk products, they will not take. So these are different people, and we have analyzed the vitamin D deficiency. And what we observed is the almost vegans have the 58% of people, vegans. And when you see the, when you analyze, almost 58% of people has the vitamin D deficiency. So, and also if you see cost wise and also sample volume wise, and for the conventional methods required almost 4 nanograms per ml of the sample, but ours we required sometimes 0.78 nanograms are the best. I feel the last one is the GCMS-MS method is the best one. So sample requirement is 1.5 nanograms per ml. The cost wise also you will get it almost with the 50 rupees you will get the test report, because the reagent which are going to use for the GC, it will be the cheaper. And also the we don't require the column specificity is also not required for the GC. And also the runtime is the for the maintenance, every instrument is required, but the for the analysis wise runtime also with the GC only in the 9 minutes you will get the results, whereas the conventional method requires 35 to 40 minutes to get the results. So this is what about the vitamin D deficiency. We have developed this rapid and cost-effective method. It can provide better sensitivity, short analysis time along with the minimal sample treatment, and so it will be more better than the conventional method. And with the new method, we can separate the vitamin D2 and D3 in the particularly. But with the conventional method, you cannot able to separate the D2 and D3. But with our method, so you can separate the vitamin D2 and D3 in the samples, and also our study report shows that especially vegans is the greater risk of the vitamin D deficiency. So this was about the conclusion of my topic. These are some of the students are working and some of the are completed my my group. So these are some of the recent reports on this vitamin D. And also I acknowledge my teacher and also the my postdoc and also my collaborator, Professor Enrenhu. He is my currently with him I have the 2 projects, and this is the during my postdoc with my boss. I purely worked on the mass spectrometry lab only, and also bioanalytical, and also is currently is my collaborator. And I think in 2018 we have myself and Krishnam Raju visited for the 10 days trip to the Suchi University and National Dongwa University. So he's also my collaborator. Currently, I have the 2 projects with him, and these are some groups because we have conducted the 2 times international conference, and 2017 and 2018. Both the times, my boss and my collaborator they have visited Nizam College and Koti Women's College, and these are my research scholars, and also from foreign students, those who are completed the work. 3 of the students are completed for their PhD. And Ramesh and Sidhu and Naresh Reddy, these are completed. So currently 3-4 students, 5 students or 6 students, they got the job in the central government patent officer and different. And right now 3-4 active students are there in my lab. And thank you all for giving me this opportunity, for inviting me for this one-day national workshop on the recent technologies in the biological and chemical sciences. So thank you very much, Karnakaranna. Inviting. This is, I think, the second.
Thank you, Murali. Just one question. Is the method is useful for the detection of deficiency of vitamin C? Only
No. This is actually we have developed because I think the chemistry you might have seen, because we have used the one is Diel salt reaction, because you can see some diene is there in the vitamin D. This method mainly used for the vitamin D, because we have applied some chemistry, because even though it is the analytical method, but for derivatization we used some chemistry. So in that chemistry, I think we used the different reagents for the trimethyl silyl group for the GC, and there that is only binding wherever the OH group is there in the vitamin D, that is binding. And when it comes to the Diel salt reaction, one diene, and where we have taken one dienophile. So we have applied the chemistry, that chemistry part with the analytical chemistry together. So that is the reason maybe we cannot use this is for the vitamin C. Means you have to see the structure. Maybe you have to. And I think one more question. Dayanand sir, good afternoon, Dayanand sir. Does the sample blood test, does a simple blood test indicate the calcium levels in body, or bone density test is also required? But for blood serum calcium, you can get the calcium levels, madam, or not, Ma Sharma, sir. And also for bone density, you have to do the separate calcium, separate test. But for that, this is both are the different. This is the serum calcium is different. The bone calcium is different. So you have that the both are the different tests.
Thank you, madam. Over to Vinayak Kumar, sir.
Sir, is it better to take vitamin D2 or vitamin D3?
Madam, it's commercially available right now only the vitamin D3 tablets, madam. But vitamin D2 only you will get it from some vegetables and some kind of algae products. But we are not eating. But some countries they are eating, madam. That this is available in some sea source, and because we are not eating. But I observed when I was in Taiwan postdoc, they use different kind of algae in their food lunch. So they said that sometime when we were discussing, they said that these are the vitamin D2 rich compounds they are saying. But I too don't know. But some kind of algae, with the algae we are getting. But in the lot of India industries like Fermento, Bio, and only they are producing only vitamin D3 tablets now, not the vitamin D2.
Okay, sir. Thank you.
Sir, good afternoon, sir. I am Dayanand, sir.
Sir. Sir.
Sir, నమస్కారం. అయితే మీరు చేసిన ప్రొడక్ట్ కమర్షియలైజ్ అయిపోయిందా సార్? అంటే
లేదు సార్, యాక్చువల్ గా అయితే మేము పేటెంట్ కి ఇందులో కొన్ని చెప్పలేదు, కొన్ని ఇంకా వేరే ఉన్నాయి. జస్ట్ టాక్ పర్పస్ ఇచ్చాము. అయితే పేటెంట్ కి వీఆర్ దిస్ టైమ్ వీఆర్ గోయింగ్ ఫర్ పేటెంట్ సార్. అండ్
ఇంకొకటి బ్లడ్ టెస్ట్ సింపుల్ సార్, సింపుల్ కిట్ సార్ ఇది. ఈజ్ ఇట్ ఏ సింపుల్ కిట్ ఫర్ టు టెస్ట్ దిస్ విటమిన్ డి ఆర్ ఇస్ ఇట్ మోర్ కాస్ట్లీ సార్? Because mass price involved there.
Sir, actually instrument is the costly.
Okay.
The method which we developed is the cheaper, obviously. But nowadays, actually, for other tests, vitamin B12 deficiency, every lab has the now mass spectrometer.
Okay.
But they are not using this mass spectrometer for the vitamin D deficiency, but they are using other purpose. LCMS is there. In the now all the labs like ICMR approved, all the labs have this LCMS, sir. For that labs they are using LCMS and only for the purpose of the vitamin B12 estimation and other estimations, but they are not using for the vitamin D. But with that instruments we can use it, sir.
Okay.
But buying the instrument is expensive, but after that maintaining is the cheaper.
Okay, sir.
First instrument, but most of the labs they have this kind of instruments, like all the labs, like not only pharma, now ICMR approved labs, everybody has this kind of instrument, but we have to use this method. We have to adapt. They have to adapt this kind of method, and hopefully maybe we'll also actually. Recently, one of the pharma, Fermento Biotech or something, they have approached us because I don't know, actually the discussions are going, and they want to because they are the largest production of vitamin D3 in the India. Their company. What they want is they want to test more people. They want to adapt this kind of method. They want to test the more people. If they test more people, automatically more people have the vitamin D deficiency, and they want to sell the more tablets. So their agenda is different. They want to give this kind of test to the more people. ఎక్కువ మంది ఇప్పుడు మనకి ఊళ్ళలో ఎవరు మోస్ట్లీ విలేజెస్ లో ఎవరు టెస్ట్ చేయించుకోరు కదా సార్ విటమిన్ డి. నాకు తెలిసినంత వరకు ఇప్పుడున్న ఆడియన్స్ లో కూడా నాకు తెలిసినంత వరకు మేబీ ఒక 60% చేయించుకొని ఉంటారు అనుకుంటున్నా, మేబీ 40% చేయించుకొని ఉంటారు. మనమే ఎట్లుంటే ఆటోమేటికల్ గా ఊళ్ళల్లో ఏమంటారు విటమిన్ డి కానీ జనరల్ గా ఊళ్ళల్లో కానీ జనరల్ గా వేరే వాళ్ళు కూడా దీని మీద అసలు ఐడియా పోదు సార్. మనకి ఫస్ట్ ఏంటంటే మనకి ఐడియా మనము దీని మీద పోదు, అరే టెస్ట్ చేయించుకోవాలా విటమిన్ డి డిఫిషియన్సీ అని పోదు. ఫస్ట్ ఎప్పుడైనా ప్రాబ్లం వస్తే ఆటోమేటిక్ ఏంటంటే టెస్ట్ చేయించుకో ఏం చేయం, ఆటోమేటిక్ డాక్టర్ దగ్గర పోతే ఏం రాస్తారు, మల్టీవిటమిన్ రాస్తారు, డి విటమిన్ రాస్తారు. మీరు ఎప్పుడైనా చూడండి, ఇప్పుడు కరోనాలో కూడా కిట్లలో ఒకటి ఉందో చూడండి మీరు, గవర్నమెంట్ తెలంగాణ గవర్నమెంట్ ప్రిస్క్రైబ్ చేసిన కిట్ లో విటమిన్ డి టాబ్లెట్ ఉంటుంది.
ఇంకొకటి సార్, వెజిటేరియన్ బెటరా నాన్ వెజిటేరియన్ బెటరా సార్? మీ అనాలిసిస్ లో 117 లో 146-47 ఆల్మోస్ట్ 50% ఈచ్ వచ్చారు కదా సార్.
ఇక్కడ మెయిన్ ఏంటంటే వెజిటేరియన్ నాన్ వెజిటేరియన్ కన్నా అది నేను విటమిన్ డి కి చెప్పను కానీ విటమిన్ బి12 కి చెప్తా. విటమిన్ బి12 కి
ఇంకొకటి సార్, అదే ల్యాబ్, మీ ల్యాబ్ లో మా సార్ ఎస్ఎస్ఎన్ సార్ విటమిన్ బి12 మీద వర్క్ చేసినాం సార్ స్టార్టింగ్ లో. సేమ్ అదే ల్యాబ్ లో మీరు విటమిన్ డి అంటే ఇట్ ఈస్ ఏ విటమిన్ ల్యాబ్ ఐ థింక్, ఇన్స్టెడ్ ఆఫ్ కాలింగ్ ఇట్ యాజ్ బయో ఇనార్గానిక్ ల్యాబ్.
విటమిన్ బి12 కి మాత్రం నాన్ వెజిటేరియన్ బెస్ట్, కానీ విటమిన్ డి కి మనం పూర్తిగా చెప్పలేము సార్. ఇఫ్ యు ఆర్ ఎక్స్పోజర్ టు ద ఇప్పుడు ఐఎమ్ ఈ సింపుల్ ఎగ్జాంపుల్, మై ఫ్యామిలీ, ఐ మై సెల్ఫ్ ఇస్ ద నాన్ వెజిటేరియన్, మై వైఫ్ ఇస్ ద వెజిటేరియన్, బట్ both have the deficiency.
Okay. Thank you, Murali.
Thank you, sir.
I hand over to
Thank you so much,
sir. Kumar sir, please.
Okay.
Prabhu.
And some interaction is going on. Okay. Thank you very much, Muralidhar Reddy sir, for your wonderful presentation. And we already experienced your lecture at our college offline. Last time you were here.
Yeah, this time also we thought same, sir.
Yes. And you spoke more about the vitamins, and also I think vitamin D also necessary for everyone. Okay, and now let's start the valedictory session now. For this, I invite our principal sir, Dr. T. Patanjali Garu, to be the chair, and I also hope he will join. And I request as the chief guest, Dr. A. Krishnamaraju sir from Department of Chemistry, Assistant Professor, University College of Technology, Osmania University, and our guest of honor for this valedictory, Dr. P. Muralidhar Reddy sir. And I also take this opportunity to invite Dr. D. Karunakar sir and Srimati Anuradha madam for organizing this online national workshop. And I hand over to Dr. Karunakar to speak a few words. After that, I request Krishnamraju sir to say a few words. Karunakar sir.
Thank you, sir. Thank you. Respected chairman of the session, and the chief guest, Dr. A. Krishnamraju garu, invitee Dr. P. Muralidhar Reddy garu, and my colleagues, students, and participants. We are very happy to organize one-day national workshop on advanced technologies in biological and chemical science. I feel the students and staff, they are limited to their own discipline. They are not doing interdisciplinary research work. This type of workshop will enlighten and gives the importance of interdisciplinary research. Especially in this pandemic situation, we need this type of interdisciplinary research work. It will helpful to improve the good results in the health sector. The present important areas that are genome technology, nanotechnology, these technology involves the experiments and concepts of biology and chemistry. So we choose this topic, this interdisciplinary topic. Day by day, new technologies are merging in science. As a teaching community, we should know something about these advanced technologies. Otherwise, we cannot analyze the students towards research. The aim of this workshop is to inculcate interest on research in young brains. In that purpose, we are arranged the resource persons, the principal, all are supported very well. This workshops covers various topics that are microbial diversity, the antiviral drug and its importance development, and water quality analysis, and nanotechnology, and mass spectrometry approaches. I express my sincere thanks to Commissioner of Collegiate Education, RUSA, for financial support, and Dr. Mamidala Praveen, Special Invitee, Joint Secretary, Telangana Social Welfare Residential Institution Society, and Dr. D.T. Chari garu, AGO, for their encouragement, for accepting the invitation. I express my sincere thanks to every resource person, Dr. K. Suresh and Professor Rambabu garu and Dr. P. Muralidhar Reddy garu and Dr. D. Ramarao, Dr. Y. Prashanti. When I asking, they're accepted immediately. They don't give any trouble to conduct this seminar. I hope the Department of Chemistry, with the collaboration of other disciplines, will conduct seminars, workshops, and conference like this. I expected the same support from the participants and resource persons. I express my thanks to Vinayak Kumar as the organizing in well manner, Bhavani, technical support, and the staff, Dr. Padma, Ramani Madam, Rajareddy Garu, Savidya, Sarvaya, and those who are not mentioned, don't feel. I express my sincere thanks to all. I hand over to Vinayak Kumar, sir. Thank you.
Thank you, sir, for briefing the webinar. Since morning, what we have deliberated with all the resource persons, and hope the participants take something for their research prospects to explore whatever the resource persons gave some idea regarding advanced technology in bio science and what including biological and chemistry. Now I would like to invite Krishnam Raju sir.
Sir, before
Sir.
The principal.
Sir?
Before Krishnam Raju sir, principal sir would like to say anything. Or Anuradha
అంటే
madam. Finally, we give the chance to Krishnam Raju.
అంటే సార్ మాట్లాడిన తర్వాత ప్రిన్సిపల్ సార్ మాట్లాడినాక
ఓకే ఓకే
మేడం అంటే ఫస్ట్ వీ హ్యావ్ టు ఇది కదా
ఓకే సార్
ఆర్డర్ లో వస్తున్నాను ఓకే Dr. Krishnam Raju sir was from Warangal and obtained master's degree in medicinal chemistry from Osmania University in 2000 and BSc BZC from Kakati University in 1997. Raju sir carried his doctoral research work at IICT Hyderabad under the supervision of Dr. J.S. Yadav, Bhatnagar Awardee, former director IICT, and obtained PhD degree in 2007. Dr. Raju sir worked as a postdoctoral research fellow at Professor J.R. Fax Laboratory in Department of Biochemistry, University of Texas Southwestern Medical Center at Dallas, Texas, USA, between 2007 and 8. Raju sir worked as a research scientist for Sai Advantium Pharma Limited, Hyderabad, between 2008 and 9, as a scientific officer in R&D for Expicor Pharma Private Limited, Hyderabad, during 2006 and 7. Sir also worked as a chemist at Dr. Reddy's Research Foundation, DRF, Hyderabad, during 2000 and 2001. Prior to joining with Osmania University as assistant professor in September 2013, Raju sir worked as assistant professor in Department of MCA at NIPER, Hyderabad, from August 2009 to September 2013. Currently, sir is working as additional controller of examinations for BSc and BA sections, Osmania University. Under sir's supervision, 29 master students successfully completed their one-year dissertation projects and received their master degrees. One research scholar was awarded PhD, and currently research scholars are working with him for their PhD degree. And sir research work has been published in over 30 articles in leading international and national chemistry journals, and also presented at several international national conferences. Sir so far delivered over 12 invited guest lectures, about 50 oral poster presentations, and participated in more than 25 international, national, state conferences and seminars. Sir is also life member of Indian Council of Chemists and Indian Science Congress Association. Thank you very much, sir, for being with us on behalf of our principal and all the staff and the participants, delegates, and the invitees. I would like to invite to take this opportunity for your precious time to be with us. Thank you very much, and over to Krishnam Raju, sir. Thank you, sir.
Am I audible, sir?
Yes, sir. Yes.
Thank you so much, sir, for your kind introduction. The chairman of this one-day national workshop on advanced technologies in biological and chemical sciences, as well as the principal of Sadasivpet Government Degree College, Dr. T. Patanjali, and the guest of honor, my dear friend and colleague, Dr. P. Muralidhar Reddy, as well as the key person, convener of this event, Dr. D. Karnakar sir, and Dr. Anuradha ma'am, who is a co-convener, and Sri Vinayaka sir, vice principal of the college. Notable resource persons, distinguished guests, invitees, organizing committee of the event, students and staff of GDC Sadasivpet, ladies and gentlemen, and friends, a very good afternoon to you all. I personally extend the heartiest congratulations to all the organizing committee members for successfully conducting this one-day national workshop on advanced technologies in biological and chemical sciences. I feel extremely delighted to be part of this successful event, which is being excellently conducted with a determined efforts of the organizing committee, staff, and student of this college. As with the objectives, I am sure that this workshop has inspired and motivated all the young students and research scholars towards the biological and chemical sciences by providing enlightening sessions with eminent personalities in the field. Conducting such kind of workshops, seminars like this is need of the hour, as it provides a common platform through which the students, research scholars get an opportunity to interact and share their ideas with diversified stakeholders in the field. Updating of ourselves with the latest technologies and current approaches has always been a very important for the students, research scholars, and all the stakeholders of this excited field of science. Based on the topics dealt and resource persons involved here in this conference today, I could feel that the participants were exposed to current advancements in various concepts in allied sciences of interesting bio and chemical sciences. My advice to all the youngsters here is that work with positive attitude, work with determination. The determination offers you best in life. The world needs resourceful young people like you. I'm confident that you are a real force for the good of others. Remember the values that you have achieved. As you are grown, there will be times when your values are going to be tested. Friends, be strong and always be true to yourself. Then no matter what happens, you will truly reach your goals. You must bring the change you wish to see in the world to start with you. And as you all know, that learning gives creativity, creativity leads to thinking, and thinking provides knowledge, and knowledge makes you great. Workshops like this will ignite creativity and innovation in your young minds and keep that momentum to make yourself best in the future. Don't compromise on your values and principles at any point of time. And a true commitment makes to become a leader in your passion, whatever it may be. Be committed, inculcate and develop the leadership skills within you, and that will make you the successor. Do your best. The hard work developing small ideas into big ideas improving research as well as entrepreneurship skills will make you different from others. Be unique yourself and don't compare with others. As you grow in your career, we trust that the skills, values, and attitudes you have learned and developed will stand by you for a bright and happy as well as successful future. I would appeal all the participants of this important conference that the knowledge gained here and the take-home messages from all the eminent personalities given to you to carry forward them towards making your goal achievable. I'm confident with the determination and constant hard work, you can realize your goals. My hearty congratulations to all the participants as well as the key person who is beyond this conference, the convener, Dr. D. Karnakar sir, and the principal of the college, vice principal of the college, organizing committee of the event, students and staff of the college on the success of this one-day national seminar. At the end, I would once again express my sincere gratitude to the convener of the event, Dr. D. Karnakar sir, and principal Dr. T. Patanjali sir, and all the organizing committee of the event for inviting me to this important event and making me part of this. I wish good luck and best wishes to you all. Thank you one and all. Jai Hind.
Thank you very much, sir, for your advice for the participants and the research scholars. Now I request in brief, as a guest of honor for this valedictory, Dr. P. Muralidhar Reddy, sir, to say a few words.
Thank you very much, sir. Vinayak sir. And respected Dr. T. Patanjali sir, the principal of Government Degree College, Sadasivapet, and chief guest, today's chief guest, Dr. A. Krishnam Raju, additional controller of the examination, Usmania University, and Dr. Vinayak sir, and vice principal of the GDC Sadasivapet, and today's conveners, Dr. Convener of the National Workshop, Dr. A. Karnakaranna, and also Srimati K. Anuradha Madam. She is the co-convener for this conference, and other organizing committee members, all the delegates, speakers, and participants. Very good evening to all of you. Let me thank the organizers for giving me this opportunity to say a few words on this closing ceremony of one-day national workshop on the advanced technologies in biological and chemical sciences. First of all, let me congratulate the organizers for conducting the very informative workshop on the advanced technologies in the biological and chemical sciences. I think from the morning onwards, the topics are the different. When it's see from the starting onwards to the till the ending. Before my topic, there is a nanotechnology related overview Prashanti Madam has given. So these are all are the advanced technologies current days they are using, particularly in the biology and chemistry. So presently also the rapid detection kit, like for the coronavirus, this is also the one of the latest technology, that is antigen antibody and the COVID-19 vaccine. These are all are under like whatever my talk, whatever I have given on the development of the rapid and cost-effective method for the detection of vitamin D. So these are the advanced technologies. So at least if you give some points from this, all these talks, maybe this workshop is the fruitful, I guess. And I hope this workshop address the challenges and issues in the chemistry and biological sciences to create the research ambience among the students and faculty members. Further, I heard that the speakers from the different fields that shared their expertise and knowledge in this national workshop to motivate the young faculty members as well as the like graduate, undergraduate students, research scholars, and also to create the enthusiasm towards the advanced technology. So I certainly hope that our renowned speakers presence and contribution on the advanced technology in biological and chemical science motivate all the presents. Finally, once again I congratulate the conveners of this webinar, Dr. Dr. D. Karunakaran and K. Anuradha Madam for their initiation and relentless effort for making the one-day national workshop a grand success. So thank you one and all. Thank you all for, thank you Vinayak sir for this opportunity.
Thank you, sir. Thank you very much. Now I request our principal, sir, chairman of this national webinar, to address the participants.
Namaste. Greetings to all who attended today's online seminar on advanced technologies in biological and chemical sciences organized by the Department of Chemistry through IQAC with our college botany department collaboration funding of RUSA. My best wishes to the chief guest, Dr. A. Krishnamraju, guest of honor, Dr. P. Muralidhar Reddy, convener Dr. D. Karunakar, co-convener Srimati K. Anuradha, our vice principal and liaison officer Sri Vinayak Kumar, our college faculty friends, as well as various college faculty and students. Thanks to everyone who made this online webinar a success. In this webinar, we have Dr. P. Muralidhar Reddy, Dr. Y. Prashanti, Dr. D. Ramarao, Professor G. Rambabu. We heard Dr. K. Suresh Picha also. Thanks to the resource persons who worked hard and provided lectures with the help of PPTs. Yet, if anyone gets the feeling that they missed a single word, there is a whole record that has been going on since morning on YouTube, can be heard again, uploaded by our computer science lecturer, Ms. Bhavani. Thanks to her. The need for us to develop knowledge in our subjects is on all of us. I hope that today's webinar has nurtured this perspective in us. I hope everyone agrees with my opinion. We first wanted to take this seminar offline, but online. Separation on online. The benefits to both are different. We also need to adjust over time. Must. Once again, I would also like to thank our Honorable Commissioner for giving us such a wonderful opportunity. Another thanks to Convener Karunakar and Co-Convener Anuradha for effectively managing the webinar. Thanks to everyone who worked hard for this event. Jai Hind.
Thank you, sir, for addressing the participants. Now I invite co-convener of the webinar, Srimati K. Anuradha Madam, to present a vote of thanks.
Thank you, sir. Am I audible, sir?
Yes, madam.
Good evening, everybody. Respected principal, sir, delegates, resource persons, faculty, PhD scholars, and students, and all other participants. You are all welcome to this valedictory ceremony of one-day online national workshop on advanced technologies in biological and chemical sciences, which is conducted by Department of Chemistry in collaboration with Department of Botany, funded by RUSA. I express my gratitude to RUSA for funding this workshop, and I also express my gratitude to CCE for supporting this conduction of workshop. I express my sincere thanks to all the resource persons till the morning. Today, we are listening so many lectures which are very much relevant to the present world situation during the corona pandemic. This workshop is relevant to the present day situation. Total world is facing a threat of coronavirus. At the inaugural session, speakers emphasized on the collaborative support of departments to find a solution for the dangerous problems which we are facing now. The efforts of the biological and chemical fields to get rid of the problems. I am very much thankful to Dr. Praveen, sir, Joint Secretary, the Higher Education, Social Welfare Residential Educational Society, and Dr. D.T. Chari Garu, AGO CCE for attending the inaugural session and enlighten us about the recent issues. And our keynote speaker, I am very much specially thankful to keynote speaker Dr. Suresh Korpol, principal scientist, who took attention on microbes, their genome content, and the topic chosen by him is very much relevant to the present corona pandemic condition. Sir has widely explained about the microbial peptides. Thank you very much, sir, for delivering speech on topic microbial diversity, unseen treasury of antimicrobial peptides. And other resource persons like Professor G. Rambabu Garu from Geetam University has delivered an informative and interesting speech on antiviral drug development in various aspects. As per view, really, antiviral drugs are so hard to develop, but the efforts of our chemists made this easy. Our other resource person, Dr. D. Ramarao Garu, Principal, Government Degree College, Ponduru, has explained the research work on water analysis at Kovada site with water physicochemical and biological parameter analysis with graphical and tabular representation by through PPT. We are very much thankful to you, sir. Other resource person, Dr. Y. Prashanti, Department of Chemistry, Mahatma Gandhi University, Nalgonda, has delivered a broad, informative speech about nanotechnology in relation with reduction of harmfulness caused by the pesticides. Her research focused on the benefits of the nanomaterials to the modern world. Thank you very much, madam. Eminent speaker, Dr. P. Muralidhar Reddy Garu, Department of Chemistry, Usmania University, delivered a talk on vitamin D, sources, deficiency, symptoms, and mass spectrometer to analyze the vitamin D. Nowadays, it has become very common to have D vitamin in doctor's prescription. So it is very much important to know about D vitamin, sir. Thank you very much, sir. We are pleased to have eminent personality like Dr. A. Krishnam Raju, Additional Controller of Examinations and Department of Chemistry, Usmania University, who enlightened about the scientific temper with values and positive attitude. Thank you very much, sir. I also express my thanks to the principal, sir, and all my staff members, teaching and non-teaching staff. Especially, I am very much thankful to Sri Vinayak Kumar, sir, for guiding this meeting peacefully. And I also express my gratitude to the Miss F. Bhavani, Assistant Professor in Lecturer in Computer Science, for giving technical support. Thank you one and all for supporting us. Thank you each and every person who made this workshop success and grand. With this, I will conclude my vote of thanks. Over to Vinayak Kumar, sir.
Thank you, madam. I hope this is the time to conclude the webinar, and I wish you all the best for all the resource persons, participants, and my colleagues, and all the invitees. Thank you very much.
Sir, shall we close, sir?
Yes, sir. Yes, sir. Yes.
Principal, sir.
Okay, sir. We will
Okay,
close.
we are leaving.
Thank you, sir. Thank you.
Okay, sir.
Thank you once again to all.
Okay, sir.
భవానీ
ఏం చేస్తున్నా సార్?
అమ్మా 1-2 days లో సర్టిఫికెట్స్ మనం పంపిస్తామని గ్రూప్ లో పెట్టేసేయమ్మా.
ఓకే ఓకే సార్.
సార్ ఓకేనా?
ఓకే సార్.
థ్యాంక్ యూ భవానీ.
ఓకే, థ్యాంక్ యూ సార్.
ఓకే.
మంటే పోవాలి మండే నుంచి అది